Okay, let's have a look at how we can transform data into some information. So this is just an introduction, and what we'll do is we'll look at some of the key processes that we might use in actually presenting our data. Okay, so our main focus is really to go from here for our data. So our data is often in the forms of rows and columns, which can be difficult to interpret for many users. So we want to convert this data into something that can make sense to someone, often in the form of a chart. So for that we use analytical tools. We often have some sort of hypothesis about what it is that we're trying to show, and then we'll use the tools to be able to show if that hypothesis is true or not. And then we'll often use some sort of charting tool to be able to map our data into something that makes sense to our audience.
Still we and them. And we is Western world, and them is third world. And what do you mean with Western world? I said, well, that's long life in small family, and third world is short life in large family. So this is what I could display here. I put fertility rate here, number of children per woman, 1, 2, 3, 4, up to about 8 children per woman. We have very good data since 1962, 1960 about, on the size of families in all countries. The error margin is narrow. Here I put life expectancy at birth, from 30 years in some countries up to about 70 years. And 1962, there was really a group of countries here that was industrialized countries, and they had small families and long lives. And these were the developing countries. They had large families and they had relatively short lives. Now, what has happened since 1962? We want to see the change. Are the students right? It's still 2 types of countries? Or have these developing countries got smaller families and they live here? Or have they got longer lives and live up there? Let's see. We start the world. And this is all UN statistic that has been available. Here we go. Can you see there? It's China. They're moving against better health. They're improving there. All the green Latin American countries, they are moving towards smaller families. The yellow ones here are the Arabic countries, and they get larger families, but longer lives, but not larger families. The Africans are the green down here, they still remain here. This is India. Indonesia is moving on pretty fast. And in the 80s here, you have Bangladesh still among the African countries there, but now Bangladesh, it's a miracle that happens in the 80s. The imams start to promote family planning, and they move up into that corner. And in 90s, we have the terrible HIV epidemic that takes down the life expectancy of the African countries, and all the rest of the world moves up into the corner where we have long lives and small family, and we have a completely new world.
Okay, so that shows probably one of the best examples of how you show information and how you can make it engaging. So often what we have to do is we have to present our information, and 6 slides or 6 sections is often the way that we would actually do it in a fairly scientific approach. So let's say that we have a presentation that we need to give. It's a really important presentation. We have possibly 30 minutes to present, and it's so important, and we want to get the message across. But we also want to make sure that we actually show the audience the information that allows them to make up their own minds, and they don't just take our viewpoints. So all along we need to be able to show basically the scope and the weaknesses of our work. So often what we do is introduce ourselves, of course, and then we have the aim of the presentation. So it's important up front that we actually tell the audience what they're actually going to see. And all along we reinforce the aim so that our audience actually know why it is that we're presenting the things that we're showing. So in order to be able to properly actually define our aim, we actually define what the problem is, what's the context, what are we trying to show, what are we trying to look at and understand and show something related to the problem. Are we solving the problem? Have we shown a new viewpoint on the problem? What is the basic context for our presentation? And then we show our basic method. Where was it we got the data? What's our approach? What statistical methods are we using? What will be the significance of the work, and so on. So it's in there that will give some sort of background in the methods that we've actually used. Again, we need to make sure that that we actually show the scope and the weaknesses of our approach at the same time as presenting our advantages. Then we present our results. So if we can, it's nice to have a nice wow moment, as you saw in the last presentation, something that really takes the audience by surprise, a new viewpoint, a new way of abstracting things. If possible too, we don't want to overload the presentation with too much text and numbers and figures and so on. What we want to do is to be able to show some sort of graphical abstraction, and then make it easy for the viewer to be able to see the results. From there we might outline what the key findings are. So in the results we're actually showing the scope of what we've done, but then we pull out some key findings here. So maybe it is here that we have our wow moment. And then in the end we want to bring it back together to actually remember the audience as to why we are presenting and why do the findings fit in with what we've actually tried to present at the end. Okay, so there's a strong linkage between our conclusions and the aim, and we need to make sure that we're answering what we actually started off with. Okay, so that's the basic cycle that we would often take to go through the main stages of a presentation, or within some sections of a paper that we were actually writing. Okay, so how do we start? Often what we start, if we're looking to do a presentation, we're looking at what's the basic point, what it is, what's your focus, why is it you want to present this information. And it's important to reinforce that as you go along. Along with this, you need to know your audience, who it is you're actually speaking to. So a good presenter will often ask who the audience is, what's their background, what's their interests, and so on, and then we'll focus the presentation and the delivery mechanisms on the audience. Is it engagement? Should it be fun? Is it a scientific discovery where you need to actually show the scientific process? Or are you trying to influence people from it? The presentation that you often give is often related to the audience that you're delivering to. You need to pace yourself, you need to make sure that you're going through the main stages and that the audience actually know at each point what the point of the presentation actually is. From there, we obviously need to know what our vehicle of delivery is. Is it a presentation, a keynote presentation, or is it PowerPoint? Are we presenting on the web, print material, video, and so on? Can we use colour? Can we use charting? Can we make it interactive? And so on. So at this point, what we need to know is how we're going to present, how we're going to deliver, and understand the basic limitations and also the opportunities that our delivery mechanism actually has. If you can provide some interaction inside the presentation, then it helps to engage the audience. Sometimes a mixture of things works quite well. You might look at video, audio, web integration, and so on inside the delivery of your presentation. Then we need to know what the type of what the options are for our presentation. Are we going to use tables or scatter graphs, bar charts, histograms, color maps, and so on? And then in the end, we really want to show what the significance and importance is of our presentation. So we need to show things like correlation models, trends, and overall machine models. So it's here that we'll actually show the audience why our work is significant and probably the scope of it. Okay, so what's your point? So we'd often start off with some question, a research question that we're actually trying to show. If possible, you want to be tried to be objective in your approach, to be quite scientific in it. That if you see any weaknesses, then you actually present them you actually present data which actually goes against the hypothesis too. So let's look at can we get more kids into coding, and can we address the gender balance with inside computing? So these might be the questions that you're asking for, so that what you want to do is to be able to present a balanced approach to that question to see if you can answer it through data. So we have quite a few ways that we can actually present our information, and really no one method actually works over the other one best. It really depends on what it is you're presenting. A good old table is often used, and that will give you numbers. The problem with that is that sometimes when you're given a presentation, it can be actually quite difficult to see what the information is that you're actually trying to portray. Pie charts are good in some situations. And we also have things like a scatter plot. So scatter plots are a good mechanism for actually showing our information. So let's look at a standard or an example scatter plot. So that's where we take an x and a y-axis and we plot onto a chart. Well-known methods, quite scientific. If we can put on other things like this line, this trend line, then it also portrays a little bit more information here. And again, we can see that we're interactive here, that we're actually showing three axes almost, that we have information on each of the dots, but we have our x and our y. If possible, always make sure that your labels are well defined for the x and y and in units if possible, and then also for the overall title. Okay, so that's a scatter chart. Sometimes what we have is what's called a frequency plot or a histogram. So with a histogram, what we have is that we take our values, okay, as they occur, and we count the number of values that we actually have, okay, and we get what's called a frequency distribution, or a histogram. Okay, there are various standard types of histograms that we get depending on the behavior of our data. This one is called a normal distribution, and we typically have a mean and a standard deviation with that. So we'll go into that in more detail. This is the triangular one, the Weibull, and exponential distribution. Okay, so this allows us to be able to see how our population is distributed. So it might be things like a death age, where we'll have a mean value, and then we'll have a standard deviation around that. Okay, a bar chart is well known. So with a bar chart, what we can do is we can plot our data with inside bars, showing us height. If we can add a bit of interaction, again, it helps them. But a bar chart is quite good, where we have possibly text or an object here, and we have a value up the y-axis. Okay, again, what we really need is to make sure that our graphs are well labeled. We can also have a time plot that might be to do with the signal. We can have color maps, which will show us an intensity value. Bubble charts, as we've seen, is a good method of portraying information. And the bubble chart allows us to show 3D information, where we can have an X and a Y, and then the size of the bubble actually represents a third variable within inside our data. Okay, again, if we can make it interactive, then it's quite interesting for the user, and we make sure that again we can color code. Color is a good mechanism of portraying information, and it allows you to be able to find things quite quickly. But generally there is something within inside here that you're actually trying to identify, such in this case we see a much larger value than we have here. So bubbles are good in terms of actually showing some sort of significance and some variation, both in the X, Y, and then also in one other variable. Okay, so those are some of the main mechanisms that we would use to be able to present the information. Okay, so here's a basic example. So in this case we have the male versus female percentage for GCSEs in England. You can see here our computing is 84% between male and female percentage. So it might be a little bit difficult to actually see that from the table and the significance, because we're also showing here the subjects which are more focused on female pupils. But then if we plot the chart, we can actually start to see. So here is our baseline, there's our 50% here. So anything above here is male oriented, anything below here is female orientated. So we can actually very quickly see the female orientated subjects here, and then with the male orientated subjects here. Again, if we make it interactive, then we should be able to allow the viewer to be able to interact with the chart. Okay, so we just plot this option here. Okay, so again a rollover is an interesting, so we can see these are the male orientated subjects, goes down to the 50% here, and then these are the female focused subjects, or there are more female pupils here than there are male. Okay, so that's allowed us to be able to very quickly identify our key information. And then we can add in a third variable here. In this case we have actually got the number of female pupils who are taking the subjects, and you can actually see the most significant subjects are the ones that are darker red here, and the ones that are the least significant with a fewer number of female students are actually in light grey. So you can see that computing isn't actually doing that well in terms of the number of female students who are actually taking the subject. And then of course we can have our bubble chart. So the bubble chart is quite good for being able to show differences in things. So we can see that a bubble over here is more leaning towards female students, and a bubble which goes more against the trend on this side is likely to be more male orientated. And then in the end what we really want to show is the significance. So there are various figures that we can use, such as in linear regression we have the R² value or the F statistic, and in this case we really want to show in the end how significant our figures actually are. So that's either by charting and showing a trend, or mathematically showing the significance of it. Okay, so that's been a very basic introduction to converting data into information.